Okay, so in today's class we will study about transform analysis. What is transform analysis? As we have studied in previous class, you can see in my previous video, that how we were transforming the DFD to structure chart. While making the structure chart, we were using two kinds of processes. One was transform analysis and other was transaction analysis. So in today's class, we will only study about the transform analysis. How from DFD we can transform the DFD to our structure chart. That was in our designing phase. Okay. So now let's see what is a transform analysis. Mainly in transform analysis, you can see here I have already made a chart how from DFD I am making the structure chart. So before that, what is transform analysis? It identifies the primary functional components that are modules. As we have studied already that what are modules, as we were breaking the whole particular function into sub functions, and then from that we were breaking those sub functions to different modules. So in this case we are talking about those functional components that we were breaking the sub modules, sub programs or sub functions into. That were our modules. Here we are just talking about those modules. As we have previously also we have discussed in previous class that we will only be talking about modules in case of transform analysis. Okay, so here what is happening, it identifies the primary functional components from the DFD, which are the primary functional components. So we are going to discuss about those particular things that are our modules. Okay, in this case also. So and the high level input output, what are the input output going to be here? Okay, this is our input and this is our output in this case of DFD. So here basically we will be talking about only three things. One is the input, output and the logical processing. That what is going on in our DFD. By thinking about these three things, these three particular parts, we will be making our structure chart. That is, we will be transforming our DFD to a particular structure chart. Okay. Now let's see what is happening here. These are our three parts. That is our input, whole process here, the whole thing, whatever is going on in this case, that is our, in this case what we are calculating the RMS. Okay, RMS calculator. So here what is happening is the input which we are giving, that is our data item. The whole thing which is going on here is our logical processing. This is the input, this is the output, and this is the logical processing which is going on. Okay, so in this case we are just calculating the RMS from the data item. Whatever data item the user is giving us, we are just taking that one, we are processing that one, and we are giving the result as the RMS. So these three things are basically going to be taken in case of this particular transform analysis. Okay, so that is our input, output and logical processing. Now in this case, what is our input? Okay, what thing we are describing about the input, what thing we are getting from the input. So in this particular case, as we have already seen, we are going to focus on the primary functional components, that are our modules. Okay, now here in this case we have to see input as, these are inputs are here called as afferent branch. Okay, inputs are called, in case of transform analysis, they are called as afferent branch of our structure chart. Now these are what input data means here, that is the transformation of physical to logical. We are just transforming the data from physical to logical. Okay, this transformation is, this kind of transformation here will be taken in case of our input branch or input data. So input data will be transformation from this physical to logical. Okay, then output data, obviously the reverse one, that is the logical to physical one. Then so from physical to logical is our input data and logical to physical is our output data. These two kinds of data are going to be taken from the DFD. Right? Now in case of output, input was called here as afferent branch, and in case of output we will call it as efferent branch. Okay, so these are the two things which we are going to take as our input and output in case of structured chart, afferent branch and efferent branch. Okay, and whatever is left back, that is, here it is afferent branch, AF and this is EF, your efferent branch. Okay, EB, sorry, AB and EB. But what the next which is being remaining here, that is our logical processing. Now what this logical processing is known here, that is our central transform. Okay, this one is CT, that is our central transform. The whole processing which is going to be in your DFD, that is the whole logical processing, that is called as the central transform in this particular case of transform analysis. Then, so this is our afferent branch, this is our efferent branch, and the middle one, the remaining portion, that is our logical processing, that is our central transform. Now how we are going to just change that one? This is the afferent branch, efferent branch, and rest is central transform. Now next step, as we have, first of all we have to identify these things, where the physical to logical and logical to physical, that is our input and output branches are going to be, input and output data are going to be identified. Next step, we are going to identify the central transform, that is your logical processing. And after that, in the next step, what we are going to do, we are just going to make the structure chart, that is this chart, from one of the functional components. Okay, you will be taking one functional component from the afferent branch, one from the efferent branch, and one from the central transform. We will be taking one component, functional component, from these three things. These three parts are only there in this case of transform analysis, that is input, output, and our logical processing, that is central transform. So we will be taking one component from these three parts, that is afferent branch, efferent branch, and your central transform. You are just taking one functional component, that is one module from these three parts, and from that thing we are going to construct this structure chart. This is our structure chart. Okay, this thing is our structure chart. Whatever you are seeing here, this is our structure chart. So this thing we are going to make from this particular DFD. First of all, you have to identify input, output, and logical processing, that is your central transform. Then what you have to do, you have to draw that structure chart by taking one component from every branch, that is your input branch, output branch, and central transform branch. Now what we have to do, we have to make the main module, that is this one is the root module. We will see it, I will make it clearly, that is we will make the root module first of all. Okay, from this root module, what we are going to see, we have to see the input and output what we are getting here from this root module, from this DFD. You have to take out those input and output until and unless you will get a particular bubble. These are our bubbles. Okay, for these bubbles you have to see at which bubble, particular bubble, you are getting the input, output, and the central transform from every bubble. But you have to see that bubble, you have to identify that bubble where you are not able to get a particular output from a particular input. In that case, when you are not able to conclude a particular output, that is you are where no output is found, or it cannot be deduced from the input. In that case, it will be stopped there. Okay, so here what we have to see, every bubble you have to identify. You have to take one component only, but you have to identify that which bubble up to which bubble, until and unless you can find that bubble where the output cannot be deduced from the particular input. Clear? So you have to see up to that point. That will be from that particular DFD, and from this main root bubble you are going to deduce that particular structure chart. Until you are getting that particular bubble, there no output you are getting. No output can be deduced. Here, how we are refining this structure chart? We are just adding some sub-functions required by these modules. When you are giving some modules, you are getting some modules, you have to see how these sub-functions which are needed by your module, that sub-functions you have to find out. You have to go on adding those things. As you can see here, we are just going on adding until and unless we are getting a particular point where no output can be deduced. At that point, you are going to stop the structure chart. Right? Now, let's see. These are the main basic idea that how you are going to deduce the structure chart from your transform from your DFD. Okay, so in case of transform analysis, so these points you have to just keep in your mind before making a particular structure chart from the DFD in case of transform analysis. Now let's see how we are going to make this thing, how we are going to just draw this particular DFD and make the structure chart. Okay, now let's see first how this is going to be constructed. This is our particular DFD which we can see here. This is the DFD. What is the DFD? This is to make the RMS. So first of all, what I am doing, I am just taking the data item. This is my first bubble. I am just taking out my data item, whatever data item I am getting. Okay, which kind of data item, that is the number or what thing they are going to give you, that is the user is going to give, that is your input in this case. Okay, this is your input. This is the, as we have already seen, afferent branch, that is our input data. Okay, in this case, now what we have to see, we have to see the first bubble. What the first bubble is giving me, that is validate input. This is the 0.1 level. We have to see here that the data which have been given to me, I have to see that whether my data is valid or not. Whether the given data, suppose you are going to get the sum of two numbers, so obviously you will need two numbers. But if they are giving you any kind of alphabet, then it is invalid data. If you are getting numbers, that is your valid data. So here what first we have to see the valid data, whether the data given to me is valid or not. This is my first function of this DFD. Then what, when I am getting that valid data, then what I am getting, this will be giving me, this will be flowing the data, that is this valid data, to the next bubble, that is my next function. What is my function now? Compute RMS. Now I have to compute my RMS. Since my data is valid, now what I have to do, I have to compute my particular RMS. So I am computing that RMS in this case. Now what is happening, this is flowing that RMS. When the RMS is computed here, what is happening, the RMS is computed. Okay, when this calculation had been done, this RMS is going to be given to the next function. What is my next function? This is display the result. This is the displaying result function. What this will do, this will take my result and this will obviously generate the result, that is my particular RMS. So in this case, what you are seeing, three kind of functions are there. This is my afferent branch, that is my output data. Here, this is my input data and this is my output data. Why I have made this one for you, so that you can know how this data is going on and how I am constructing the DFD, particular DFD for the RMS calculation. Since we are going to get the structure chart from this DFD, first of all, you have to understand that how we are making the DFD in this case. Every point you have to see. So here what we have seen, this is my data item, this is my input and this is my RMS, that is my output. But remaining things, these are the particular things which we are calling as central transform. This is our central transform, that is logical processing. What kind of processing is going on within this particular DFD, within your particular software, in this case your particular software. So these things you have to keep in mind, these three things. Mainly when you are making this structure chart, you have to basically see this particular things. Now you can see easily, you can identify how the RMS DFD is going on. Everything is clear. Now let's make the structure chart from this DFD. Okay, now here we have the DFD already there. Okay, now I will show you how we are going to make the structure chart. So first of all, what is happening here? What was the first point? First point was we have to make the root module. Okay, so this is my root module, that is the main. This is called the root module. This is your root module. everything will be generated within this root module. Now what I have to see, that is what from the root module we are going to get? Some functions. Then here what we have? We have 3 functions: validate the input, compute the RMS, and display result. Now we have to create the structure chart. How we are going to create the structure chart? Let's see. First of all, you have to give 3 boxes. That is your particular 3 functions. This is my first function, this is my second function, and this is my third function. Now what I have to see from this particular DFD? What is there? Validate the input. Now to validate the input, I have to get the input. So to get the input, what I have to do? Get some good data. Get good data. Or you can write anything. Getting the input, getting the correct input, anything. Getting a good data, that is a valid data, or getting the valid data. Then now what is happening when you are getting a good, for this particular function, getting a good data, what will happen? You will get the good data, and what you will do? You will send that, you are validating that data. How you will be validating that data? Now from here we will have 2 functions, 1 and 2. What is that? You are getting the data from the main. Your user is giving you the data, right? That is you're getting a good data. Now what? This data, particular data, now we are giving here reading the input. What is happening here? First of all, we are reading the input. In this case, user is giving you the input. I am reading the input. What is my input? Now what is happening? Whatever input I have read, I will send that input as data item. Done? So this is my input which the user is giving me. I am reading the input. Then what? I am sending that input, that data item, to my getting good data. Yes, I have got a good data. The item whatever I have got, that I am sending to that this function, that is getting a good data. Now what will happen? This data item, we have got a particular input. I am not validating it. Now I am going to validate it. That is validate input. First of all, you are getting the input. Now you are validating the input. In that case, data item is going here in this function, getting good data. Yes, I have got a data. Now I am sending it. This data item, I am sending it here now for validation process. I have got a data here. This data I am sending here in validate input. Clear? Now what? This is validating my data, whether my data is valid data or invalid data. Now what is happening? It will send, if this data is valid, it will send this valid data to again this getting good data. Now the function of your getting good data is complete. It will now send this valid data to the main. This is my particular validated data. Clear? Now your data is valid one. So this portion function is now complete. That is your this function, validate input. Why we have broken this one? As we have studied that from a function, you have to, in a structure chart, how you are going to refine the structure chart, how you are going to make the structure chart more in a more refined way. So you have to do what? You have to going on adding some sub functions, right? So in this case, what if I am giving you data, you are validating and you are giving that one? No, we are going to refine that one. I am getting the data, right? Now I am validating the data. So two functions, when I am breaking these functions into two functions, my particular thing, whole thing will be, structure chart will be more refined, in a more refined way. You have to make in such a way. You can write in one function also, but when you are breaking it into sub function, it will be more clear and more accurate for you. Your structure chart will be looking a very accurate one. It will be very helpful also, right? So I have done this particular thing, that is I am reading the input and I am validating the input, right? So reading input, data item is going here, I have got a data. Now I am sending that data to this function validate input. It is validating my data and again sending. Now what? I have got a valid data. I am sending this data to the main. Clear? This particular bubble is complete now. One component, input, output, transformation complete. Now we are going to take the second data. Clear? How I was talking about, for every process what we are going to get one particular component from the input, afferent branch, efferent branch and central transform. Here afferent branch you are getting this, efferent branch you are just giving this, and this thing is whole going on in your central transform. Complete for this bubble. Now let's go to the second bubble. Clear? What is happening in second bubble? Now I have a valid data now. Then now what I have to do, from this valid data I am sending this valid data, okay, from main I am sending this valid data to what? Compute RMS. Compute RMS. Now here what will be happening? This function will do what? This will compute my RMS for me. It will compute the RMS for me, right? Now what I will do, as I have already got the RMS, this will give me the RMS. That is, here you have got the RMS. Now what will it do? It will send that RMS to the main function, that is the root module. That here also same thing is happening. Computing the RMS, valid data is being given here, RMS, computing RMS, RMS going to the main. Same thing. Then now let's go to the third bubble. Right. Here third bubble, what is happening? Displaying the result. That is, display or write your result. Now how I will write that result? This main function will send the RMS to my display result. Here what you are seeing, display result is giving you the output. But here nothing is going to be there. The input is not sufficient that we cannot again do a particular circle. Up to this point it is being stopped. So this is the point where I am stopping. Since the display result I am getting the RMS, now the write the result. So here the RMS, it is sending me the RMS, it is sending me the RMS and I am giving it the particular result. Bus stop here. Up to this stop. Since after that there is no such input, this RMS you have got sufficient. Now this RMS further this cannot be an input, since you are not able to conclude it. That is, no output can be concluded from this input, since you are getting the final result. So up to this we will stop here. This is the process in transform analysis, how we are going to make our particular structure chart from the DFD. You are getting the DFD, you are making the structure chart step by step by taking every bubble until and unless you are getting a bubble where the output is not concluded from the input. Input is not sufficient that can give you a particular output. At that point your structure chart will stop. But until you are getting that one, your structure chart will go on. Correct? So here you are getting the whole thing, how the whole process is going on. From this DFD, making of DFD, to getting the points, input, output and transform analysis, you are getting central transform, then you are making this whole chart. It is very easy. Making of this chart can be seen as a complicated one, but it is very easy to make your chart. Just you have to see the input, output and the basic central transform. What is the logical processing? Just take one by one. You are just taking bubble by bubble from one function. These are what? These bubbles are basically, these are functions. These are our entities. These whatever thing is going on, these are the functions. What things are going on here and how this data is flowing. So this thing here, what function is going on? Validating the input. We are getting this from this get good data, validating the input. Next compute RMS and next showing the result. This is sufficient for this kind of DFD. Done. Now one basic thing, one more thing that is there, that is what is factoring. Okay, factoring is what, in this case one question comes that is your factoring. What is factoring? Okay, so factoring is what, in this case, when the functional components, as you have seen here, the functional components, when functional components, okay, they are broken down into sub-functional components. These are what? Our sub-functional components. So these sub-functional, breaking of the functional component into sub-functional components, this thing is known as factoring. Okay, this particular thing is known as factoring. Now, what thing we are getting from this factoring? We can get what? Adding. We can add read or write module. Here what? Here you can see, here reading some valid data, you are reading that one, you are writing something, writing the valid data. So this thing is what? From the main function I am getting these sub functions. How these sub functions I am getting? So reading and writing modules I am making. So in this case, reading and writing modules, right? Second one is error handling can be done with this. Error handling, okay, error handling module. How the error is being handled. This kind of module can also be achieved from this. That is, a functional module can be broken down into error handling modules also, where you can handle some error. If some error is there, you can handle that error. You can correct that one. You can find that error. In this case, it is not there, but in other cases also, you can give this kind of module also, sub function you can also make. That is your modules. Okay, and initial or termination process, that is your initialization, okay, or termination process. Termination process can also be shown here. That is your logical processing. What is the, how we are initializing this one and how the termination is going on. So from starting to ending processes, these processes can be, the function can be broken down into sub functions which will be showing you the initialization and the termination process. This can also be shown here. And the last one, if some customer is identifying module is there, that can also be shown here. So these things, when we are breaking the module, particular module, when functional component, this is our functional, when we are breaking it into sub-functional components, this thing is called our factoring, which comes in your exam. What is factoring? So that in that case, you will be writing the breaking of functional components into different sub-functional components. That is known as your factoring. And the factoring process, by the factoring process, what we can get some read-write modules, some termination or initialization or termination processes, or some error handling modules, or some customer identifying modules. So these can be identified from your factoring. So in this class, what we have studied, how we are making the transform analysis. That is, making the DFD, we are getting a structure chart from the DFD by using the transform analysis process. In next class, we will study about the transaction analysis. How we are going to make a particular structure chart from DFD to our transaction analysis. How we are going to make that one. Okay. Till then, if you have any kind of doubt, anything, then you can ask me in the comment section. And if you like my channel, please give a like and subscribe it so that we can discuss some more technical topics. Thank you and take care.